Hey everybody, thank you so much for joining us today. Really exciting to see all of you here. I hope you're having a wonderful I.O. I'm Meg Risdal. I'm a product manager at Google where I work on Kaggle as well as our open models.
And I'm Neel Kovelamudi. I'm a software engineer working on the Keras team here at Google.
And in today's workshop, we're going to walk you through how to create a fine-tuned Gemma model using tools and platforms like Keras and Kaggle. But before we dive in, we kind of want to contextualize the tools that we'll be using and how they fit into kind of how we view the ML landscape together. And we'll do a little bit of an intro of the tools as well. So one thing that even maybe at I.O. we've all surely felt is that the AI ecosystem is really exploding. There's a lot of different ways that all of us are experiencing this today. One way that I really like to look at it is just looking at the number of tools that are out there that you could possibly using to take advantage of the capabilities of the latest wave of generative AI. And so you can see this chart looking at the number of GitHub repos of different AI applications, tools, etc. And it's just this huge, overwhelming landscape that machine learning developers and other folks in the field like us all in this room are trying to navigate. It's a lot. At the same time, one thing that really excites me is that this exploding landscape is really being propelled in a large way by the community. A lot of innovation is coming from the community. So you can look at things like the community itself and things that the community is sharing on platforms like Kaggle and Hugging Face. Plus, like I mentioned, there's lots of different tools being created by the community. Lots of great open source tools like LangChain, Ollama, and so forth. And this is all what's really enabling all of us to make a ton of tremendous progress together, which is really exciting to me. But it's a lot. Fortunately, the good news is that Google provides resources and tools that help you both benefit from and contribute to community innovation. And we'll be talking through some of these tools today, like Kaggle, Colab, Keras, and Gemma, Google's open models. So let's talk a little bit more about each of these Google resources because we'll be using each of them in the workshop today.
First up, we'll be using Kaggle. Many of you may already know Kaggle as a machine learning competitions platform, but it's way more than that. It's a large treasure trove of over 350,000 data sets, nearly 3,000 models and growing, and millions of notebooks and more, all contributed by our vibrant machine learning ecosystem and community. All of these are stress tested and validated by the community. With so many people participating in competitions on Kaggle, it's a great place to build your machine learning portfolio. Next up, we'll be using Colab's IDE and compute environment. Many of you may already be familiar with Colab to run your code. It lets us access accelerators like TPUs and GPUs, as well as virtual machines, all free of charge. Alongside 10 million machine learning developers who use it today, it's a great workhorse to start creating and innovating today with AI. Then, of course, we'll be using Keras, more specifically Keras NLP. Keras, as many of you may be familiar with, is an open source machine learning modeling library that's known for its simplicity, ease of use, and its powerful flexibility, with options to run your models on JAX, PyTorch, and TensorFlow backends. Keras NLP is a more focused extension of Keras for natural language processing components. It comes with useful presets, state-of-the-art modeling architectures that can be used out of the box on a wide variety of downstream use cases, such as language models.
Cool. And finally, we'll be using a model from Google's family of lightweight, state-of-the-art open models that's called Gemma. We'll learn more about each of these tools and resources, including Gemma hands-on in this workshop. Promise we're getting there soon. So this kind of takes us to our workshop goals. You can kind of see how things start to piece together. We're going to be using tools like Keras NLP and Colab and Kaggle with Gemma to fine-tune and use our own customized Gemma model. And not only that, we will share it with the community on Kaggle for others to use in their applications. So before we get started, one last thing. I want to talk just a little bit more about Gemma, because everything that we're going to be building today is based on an extension on top of Gemma. So I want to dive a little bit deeper into Gemma. So again, Gemma is an open model based on the same technology that was used to create Gemini, but it's open. So it gives us, as developers, more flexibility to do things like fine-tuning that we'll be doing in workshop today. Google's goals with Gemma are threefold. First, democratizing innovation. Second, accelerating model development. So maybe you saw in the I/O keynote yesterday how Gemma has been extended by the community to create variants, fine-tuned, trained on Indic languages. So really taking advantage of building out more kind of multilingual capabilities of the models as a great example. And then third, fostering trust and responsible AI. You may have also heard in keynotes yesterday about the upgrades that we've made to our responsible AI toolkits. Encourage you to check that out after the workshop. And Gemma is really part of a long legacy at Google of innovations that have been grounded in open development, starting with things like Work2Vec, TensorFlow, TPUs, JAX, and transformers, Keras, and most recently, of course, Gemma. And it's really been, not just bringing these things to the world, but then seeing how the world takes this, builds on it, extends it, and the kind of impact that's had that we're really excited to walk you through how to do in our workshop. And so I will now hand things over to Neel to start the workshop. I'll step off stage. If anybody has any questions as Neel walks through the first half of the workshop, wave me over and I'll try to help out.
Great. So for this tutorial, feel free to follow along in the Colab at the URL above. I'll give everyone a few seconds to type that in. And without further ado, let's jump into the Colab. So as you can see here, I've pasted the link at the top if anyone still needs it. In this demo, we're going to go over how to fine-tune Gemma on a Kaggle dataset and share your model with the community. In this demo, we'll be using a medical Q&A dataset from Kaggle and fine-tuning Gemma to answer questions about some very complex medical conditions. First of all, you'll need to get access to Gemma. For this, you'll need a Kaggle account, and you need to accept the license for Gemma on Kaggle.com. You can see here there's some setup instructions linked. As you can see, you need the Kaggle account. You can go to the Gemma model card. And as you see here, I've already requested access to Gemma, and I've consented to the license. After you've successfully authenticated your access to Gemma, all you need is your Kaggle account information. You'll need to configure your Kaggle API key in settings and need a way to bring this into Colab into its environment variables. As you can see here, I've put in my Kaggle key and Kaggle username on this left-hand secrets pane in Colab. Using the user data module in Colab, I can then import these into my Python environment. And that's all I'll need to get access to Gemma as well as my Kaggle account within Colab, as you can see I've done here. Next up, you'll need to select a runtime with sufficient resources for fine-tuning an LLM. Since this is a very computationally intensive task, we highly recommend using a T4 GPU or an A100 GPU. We recommend an A100 GPU if available. As you can see here, I've already connected to an A100 on the top right. And lastly, after you've done all of this, you can start installing dependencies. For this tutorial, we're going to be using Keras, Keras NLP, as well as the Kaggle Hub library. As you can see, I've already installed them. Now, we'll just need to configure Keras and import Keras. Keras is a very strong and powerful high-level framework that allows you to access multiple backends. So you can run Gemma on TensorFlow, JAX, or PyTorch. For the purpose of this tutorial, let's configure the backend for JAX. In Keras, it's very simple. Before you import Keras, just set the Keras underscore backend environment variable to JAX, as I'll do right here. And then we're just going to go ahead and import Keras, NLP, as well as the CSV package. The CSV package here we're going to use is just to read in medical questioning and answering CSV for fine-tuning our model. As you can see here, I'm loading the model using Keras NLP's from preset API, and I've chosen the 2B variant of Gemma from Kaggle. You can see the model page over here, linked. It shows a lot of the model details that are important to see, as well as different variations of Gemma you can import. You can also see example use cases within Keras NLP, such as how to fine-tune, how to hit generate to do text generation. So this is a great one-stop shop for all your Gemma needs. Once that's fully brought into the environment, let's look at the model structure. As you can see here, this very clearly outlines the structure of the Gemma model, the 2B variant. You can see one of the most powerful things about Gemma is its massive vocabulary of over 256,000. You can also see that this corresponds with the token embedding layer's output dimension. The token embedding layer essentially takes raw string inputs, such as text and language, and brings it into word embeddings that can be understood by the model. It uses the tokenizer vocabulary as well as these token IDs over here. The padding mask is very helpful for allowing our model to accept variable input sequences of various lengths. You can also see that the amount of parameters in the backbone of the model is 2.5 billion, corresponding to the amount of trainable parameters. This is why it's called the Gemma 2 billion variant. Next, let's go over our data set. So we're going to be using this helpful healthcare NLP data set I was able to find on Kaggle. And it contains a large amount of sources as well as ways to input them into your environment. But the easiest one for us to use is simply a CSV. You can see here that there's a lot of question and answer pairs from reputable sources such as the NIH. So this would be very useful to fine-tune our model on. To simply import this into our environment, all you need to do is copy the API command and specify which specific file you want here, medquad.csv, which, as you could see, I've already done here, but let me just do it for good practice. You can simply paste the API command and specify the file. I'll download that dataset CSV. And then I'm going to go ahead and unzip the file. After unzipping the medquad.csv file, we should then format our data from the CSV into question and answer examples that we can understand and the model can understand. Since this is a language model, it can't take in the sort of tabular data we have in our CSV, so we need to format this. We're going to be using a very simple question and answer template corresponding to the questions and answers columns within the CSV. You can see that I've written this little for loop over here to go over and format things into that template. And now let's take a look at an example to make sure all our data has been formatted correctly with the Q&A template. So now that we have our data in a format that both us and the language model can understand, let's go ahead and look at inference. So the original Gemma model already, as you may know, has a lot of general knowledge it's been trained on. It can easily answer questions about a wide array of topics and a lot of common medical conditions. So to test Gemma, we're going to go ahead and pick a far more complex disease. For this one, we're going to be using chronic eosinophilic leukemia, which is a very specific type of leukemia. Let's prompt Gemma by asking about treatments for the disease, making sure to format our prompt into the question and answer template we just previously defined. As you can see here, I've formatted it in the question part of the template, and the prompt will be in this format. And we're just going to go ahead and hit generate. This should take anywhere from about 8 to 10 seconds on an A100 GPU. So we have an answer from the model. So it defines it as a rare type of blood cancer that affects the bone marrow, and it also associates it with an increase in white blood cells called eosinophils. This is a pretty good starting prompt response from the model, but it doesn't really answer the question we asked, which is what are the treatments for this disease? So this is where fine-tuning on our medical dataset can definitely help us. We can take the question and answer pairs that we got from our Kaggle dataset and fine-tune our model to give better responses. Let's go ahead and go to fine-tuning. So when it comes to fine-tuning a large language model, adjusting all the weights is a very laborious task. To get better responses from the model more efficiently, we're going to be using a technique known as low-rank adaptation, or LoRA. The way LoRA works is it freezes the original weights of the model and appends trainable weights on top. Then, when fine-tuning is run through, it'll be adjusting those added LoRA weights on top. You can choose to configure the dimensionality of those LoRA weights that you've added on top. Lower numbers or lower LoRA ranks means that there will be less trainable weights on top, which might mean potentially less precise adaptation from fine-tuning on the dataset. However, a higher rank means more detailed changes are possible to LoRA weights, but this also means more trainable parameters and correspondingly a longer fine-tuning time. A good general practice for fine-tuning is simply starting with a lower LoRA rank and working your way up after you evaluate the performance improvement on your task from fine-tuning. I'm going to go ahead and enable with a LoRA rank of 4. As you can see from the model structure, these counts are different from before. You can see that now 2.5 billion parameters are now non-trainable, which corresponds exactly to our overall number of parameters in our previous model summary. You can see this small amount of trainable weights that have been appended on top of the model, which is about 5.2 megabytes. So LoRA is now configured, and we can go ahead and run fine-tuning. So fine-tuning on this model can be quite a time-intensive process, can take anywhere from 8 to 10 minutes on an A100 GPU. I've made a lot of changes to make sure that we're controlling memory usage as well as limiting the amount of time. One of them is limiting the input sequence length to about 128 in order to control memory usage. I'll also be using a very common optimizer used for fine-tuning transform models, the Atom W optimizer. And additionally, we're going to be using cross-entropy loss, which is going to allow us to compare the model predictions with the data given in the MedQuad dataset. And according to that loss, the model is going to adjust its parameters and iteratively improve over time. You can see that the ETA is a little long. So as a result, for the sake of time with this demo, I'm going to switch over to a Colab where I've already gone ahead and run all of this fine-tuning. You can already see that many of this is exactly the same as before, and you can see the result over here. It's gone over all of the examples, 16,000 examples in the dataset. Took about 10 minutes. And now let's see how the model responds post fine-tuning. You can see that the response is a lot better. You can see, first of all, that the model is specifying specific instructions for treatment for chronic eosinophilic leukemia, such as chemotherapy, bone marrow transplant, immunotherapy, but even more specifically, it goes in and shows specific chemotherapy drugs, such as anthracyclines, vincristine, cyclophosphamide. So this is already so much of a better response simply by fine-tuning on this questioning and answering data set. Now that we have a fine-tuned model that is giving better responses, let's share our findings with the community. I'm going to go over and hand off things to Meg to talk about publishing to Kaggle and how you can contribute to our community.
Cool, thank you, Neel. So we can pull back up the slides. Now that we have this fine-tuned Gemma model, in the next half of the workshop, we're going to learn how to publish it to Kaggle's model platform, as Neel said. But you may be wondering, why? Why do I want to publish to Kaggle specifically of all places? So before we dive back into the Colab, I'm going to talk through a little bit about publishing on Kaggle, why we do it, and so forth. So like Neel said at the start, many of you probably know Kaggle as a competitions platform, and we have been for a long time. And really, over the period of the last 10 years or so, the place that Kaggle has, and our community has really found in the machine learning and AI industry is as what you see here is this crucible for what works, and importantly, what doesn't work against different machine learning and AI tasks, challenges, problems. And crucible really means that we have kind of an empirical framework for objective evaluation. We also have a community that provides the kind of social signals that tell you something is good or bad. And then what works can include ideas, techniques, frameworks, and in the case that we're interested in today, models. Just like all these other sorts of resources, we can see which models work well and which models don't work well for various machine learning tasks through Kaggle's kind of crucible, so to speak. Kind of stepping back, how does this actually work in practice? It's quite simple. But to maybe kind of frame things, I don't know about you, but sometimes despite everything I know about Kaggle and what does really work well, I still try to go at a problem solo. There's only so far that you can get when you do that. Even if we may have some 10x engineers in this room, there's really only so far you can go when you're trying to go at something alone. What if you could be a 1,000x engineer, a 10,000x engineer? This is really what a Kaggle competition is in essence. But it's not just one person, it's hundreds and thousands of participants who are all working independently, just like you might be. But they're working in this kind of what we call an embarrassingly parallel structure, where they're all working towards a single problem. But the kind of very special, unique thing about Kaggle is not only are they working independently, they're doing things like sharing knowledge and resources and code along the way. That's openly shared throughout the course of a competition. So all of those different submissions kind of go through this objective evaluation and ranking that I mentioned, but really importantly, the community is sharing knowledge about their failures, they're sharing knowledge about their successes, and all of that kind of contributes to a rising tide that lifts all boats. We have a new baseline for what we consider state-of-the-art or standard in machine learning. So when you publish something on Kaggle, I realize that was very abstract, but when you publish something on Kaggle, it gets battle-tested and hardened through this process. So some other reasons why you might want to publish on Kaggle, whether it may be today like a model, or also a data set, a notebook, or even a discussion post with some of your thoughts. There's a bunch of different reasons, some of which is feedback. So getting feedback from the community on your work, a great way to then kind of improve that work. It can be a great way to just reach a community with your ideas. So if you've got something that you think could be really popular, reaching that through the Kaggle community is a smart idea. And then last, your portfolio. So it can be a great way to kind of showcase to the world how, the kinds of things that you're capable of and the kind of contributions that you make to the community. Build up your ML portfolio. A lot of folks come to Kaggle to do that. And then, of course, it's something that organizations can do as well. Kind of building out a reputation for your organization, your company, your research lab, et cetera. So what does this actually end up looking like on the website? I actually encourage you to check out kaggle.com/models. You can see examples of this kind of in the wild. But here we have a screenshot of the Gemma model that we've been using today. And there's a couple things I wanted to call out on it. First is upvotes. So I mentioned earlier, kind of like social validation. You can see, hey, the community really likes this thing. It's getting their attention. And then really, really significant is the code tab. Highly recommend checking out the code tab of models you might be interested in. And this is where you'll find how Gemma is actually used in the context of different machine learning tasks through competitions, and it's all being done in our Notebooks platform, which is a reproducible environment, and it's all the code that's publicly shared is Apache 2.0, so it's things that you can go and yourself take and remix, and you can see a lot of different ideas about how this model and all models are used in practice by the community. Last, kind of coming back then to this idea of objective evaluation ranking, we've recently kind of exposed this new models tab also on our competitions platform. So if you go to any competition on Kaggle, you can often see all the models that are being used in that given competition. So this is a view of a LLM prompt recovery competition, and you can see the models that the community is popularly using. You can sort by popular, but you can also sort by best notebook scores. You can see which models are actually useful or less useful in a particular task. Even better, you can actually drill down into those models and see all the notebooks that the community has shared on top of them to get a real idea of how, in practice, it's being used. So that's the kind of thing that, it's kind of the magic that can happen when you publish a model, like we'll be doing in this workshop. And so I'm going to hand things back over to Neel. You can continue to follow along in the Colab. And again, if you have any questions for me, I'll be down on the floor and just raise your hand. I'll come by. But back over to Neel.
Great. So once everyone's had some time to bring this Colab into their laptops, let's dive right into the Colab right now. So we'll be focusing on the last section, which is uploading your model to Kaggle. Uploading your model to Kaggle is such a simple process thanks to integrations between Keras, Keras NLP, and Kaggle. All you need to do is first save your Gemma LM to a preset. We'll call this one Medical Gemma since it helped us with treating a medical condition. It is a very, very large model at the end of the day, and so saving can take some time. Next up, all you'll need is a Kaggle URI for your model. Use your Kaggle username as well as the model name, which in this case is Gemma, and your variation name. In this case, we called it Medical Gemma. So I'll give this time to save. Great, so the preset's been saved, and you could see this is what our URI looks like, containing my username, the model, and the variation. We're going to go ahead and upload the preset to Kaggle. All you need is the preset and the URI. While this uploads, I'm going to go over all the featurization on your own work page. So you can see this is my Gemma repo. It contains all of the variations of Gemma that I have worked on. All the different variations, my Gemma, treatment expert, and this one, medical Gemma. A new version will be uploaded soon once this finishes. It's uploading the way it's right now. There's a lot of amazing features you can do on this page to tailor your portfolio of models. You can see here that once I've uploaded the model, there is this file explorer that contains the model structure, it contains the weights, it contains even the vocabulary associated with the tokenizer. You can look at different components of the model as well, such as the entire task model, which contains the backbone, the preprocessor that contains the tokenizer, and everything. You can just have only the tokenizer. You can also just look at the preprocessor or just the config of the backbone of the model itself. Please note that this JSON is not fine-tuned for task-specific things. Use this task JSON for that. All of these are readily integrated with Keras' saving and loading APIs, so you can simply take this JSON and load a model. So with that, you can even download directly small files from within this and don't need to download the entire thing. Also, you can put some example use cases for your code. So once your user has imported this model, what do you want them to do with it? You can put all those examples here. Also, you can keep track of all the different versions of that variation here. And you can edit model details. This contains a very useful template to describe what your model does, what kinds of hardware or software you'll need, any sorts of implementation requirements, and more specifically, and this is useful for us, the training data it was fine-tuned on. So you can put the MedQuad dataset link over here. This helps any users of your model see how it was trained and how it can be used. You can also even customize the name of the model. It doesn't need to be called Gemma if you don't want it to be. And a catchy subtitle you can put on too. Once either you or other people look at your code and start creating notebooks out of it, all of the model notebooks will show up here, including your work and ones that are shared with you. Most importantly, of course, you're going to want to change the visibility to public. This is going to enable all members of the Kaggle community to come in and use your model. As you can see here, I've even added a contributor, Meg, my co-speaker. So let's go back. Looks like everything has uploaded from the side of the notebook. You can see through this link, it directly links me to that specific variation. And it could take some time to process, but once it's done, it should look very similar to this. And you have full customizability over your model page. So that's pretty much it. We've learned how to fine-tune a Gemma model on a medical questioning and answering dataset and sharing it with Kaggle. I'm going to hand things off to Meg to further wrap up.
Awesome. Thank you so much, Neel. Last chance to grab the URL if you'd like to work with the model a little bit later on. So yeah, I'm going to wrap things up for us. So in this workshop, we learned two main things. We first learned how to fine-tune Gemma, and we did so using resources like Keras, Colab, and Kaggle Models. And then second, we learned how to share these contributions and really help to propel that innovation we see from the community using Keras and Kaggle to help others in the community and get feedback or whatever our goals may be. And we can't wait to see what you do. Please share with us. And the really cool thing is, in that kind of massive ML ecosystem where there's a huge number of tools, we kind of shared a kind of way to navigate that through really nice integrations through the tools and things that Google offers. But the good news is that for each of these, they're open and usable and extensible in a broader ecosystem too. So there's even more things that you can build, whether it's Gemma and all of its integrations with the ecosystem, Kaggle, whether it's all of its resources and competitions that you can take advantage of, and then lots of resources for Keras. So more models beyond just Gemma. We're excited to see what you build with all of it. So thank you so much for joining us at this workshop today. I hope you have a fantastic I/O.